Okay, we've been talking about the FTC, or the Fundamental Theorem of Calculus Part 1 and 2 for a while now. So, certainly I'll go through this. It's a very, very short lecture. We do need to get to examples. People often confuse this material, all right? They get confused by it. I'll try to go through this in a very brief way, but you should be familiar with FTC Part 1 and Part 2 at this point. So I'm going to go to the whiteboard, and give me a moment to do so. I got to actually get my whiteboard working here. Give me 1 second. Turn things on here. And give me a minute here. And what page are we on? Because I have to load the notes into my whiteboard now. Page 471, right? And I know it's a long document, by the way, 471. We're close to the end, I'll say that. 471. And yeah, I know it's a lot of material for students. They're not used to such level of material being covered in a class. But anyway, let me go to my whiteboard. And a new share, right? All right, let's read it to you. I think probably at some point this should be pretty clear to you that we've been doing this for a while now. FTC stands for Fundamental Theorem of Calculus, and there's two parts to it. So let's get my little marker out. And I guess we're going to talk about FTC Part 1 here. So if f is continuous on the interval between a and b, and ft, the little ft equals f prime of t, then we have this statement over here. This makes doing these problems super simple, provided you can find the antiderivative. If you can't find the antiderivative, this is not going to make anybody's life easier. All right. Now, you should also recall that there's other ways to write down the fundamental theorem of calculus, and yeah, we're going to do part 2. So let's write this down. This seems a reasonable statement over here. I'm just rewriting this like this. That's all I'm doing. That seems like a reasonable statement. Then what do? Which may seem completely unreasonable too. They differentiate both sides. All right. So let me write down what they're doing. They're differentiating both sides. So the left side and the right side. And what do we know? I don't know the left side. This looks crazy to me. What I do know is this, though. I know the derivative of big F is little f. So what are we going to get? We're going to get this guy right over here. That's not going to be a shock to me. And why is that? This big F evaluated A. A has nothing to do with X at this point. So it's going to be a constant, or at least it's not changing with respect to X. It's 0. So we just get F of X. All right. This allows us to differentiate integrals. You're going to see questions where we're going to ask you to do that. You're going to be confused by it. This is the part you should not be confused by. This is the thing you should remember. And the reason for that, no matter what I put down, if you know that, you know part 2. You really do. As we go through examples, we'll try to make this more clear to you. Thank you.